Alrighty, we're going to do the Hydrate Lab here for you, and you're going to do lots of recording and observations as we take this hydrate and heat it up to get the water out of it. Okay? So the first thing I want you to do is, we're going to refer to it as hydrate the whole time, but you got to know what it is. And it is copper 2 sulfate. That would be a Roman numeral 2 in parentheses. So I'll repeat that. Copper 2 sulfate pentahydrate. Now, you might remember the very last percent composition problem you did was figuring out theoretically how much water is in this. So we'll be able to, when we do our calculations, see how close we are to that. Okay? So we're going to take some of this hydrate. So the first thing, and you want to be as specific as possible when you are when we're saying what we're going to do in the lab. And the first trial we're going to take, and we're going to use crucible, and we're going to use the crucible with the cover. I want to weigh it in case, maybe some of the solid sticks on the cover. So we're going to weigh the cover and the crucible. So you can do this in a data table, you can do this in written form, but the lab needs to be reproducible. So here is the mass of crucible and cover. 21.71 grams. Okay, that's the crucible and the cover. And then what we're going to do is we're going to take, this has a cap on there because you don't want it to dry out, especially in this super dry weather. It can actually dry out. We're going to put, so you can just see this is kind of a nice little blue crystal, kind of pretty. And we're going to take 2 little shovelfuls, about that size. So you can just say 2 scoops in the lab report. So 2 scoops of the hydrate. Okay. So now we're going to record a second mass. This is crucible, cover, and the hydrate. Okay, that is a mass of 24.50 grams. And I'm going to walk you through this first calculation, and then you're going to be on your own doing the calculations in the second and third trial. Okay, so one of the things that we can figure out right now is by subtracting the mass of the crucible and cover, we can figure out exactly how much hydrate we added, and we're going to need that for our calculations. So let's go ahead and do that right now. You take 24.50 minus 21.71. You might want to write down what you're subtracting because that'll help you, like I said, in the second and third trial. So you're going to take the mass of the whole thing with the hydrate and then the whole thing without it, and you'll get the mass of the hydrate. So that gives you a value of 2.79 grams, which is a pretty good amount to start with here. Okay, so now we're going to light the Bunsen burner. Oh, and we're going to use the clay triangle to hold the crucible. Okay, so it's just kind of a nifty little thing. It just nestles right in there. Just a little triangle shape to it. Hold it against my shirt there. And boom, and you snap the cover on, and it actually just sets on there real nice. And then you put that on this the little ring, which of course goes on the ring stand. Turn the gas on, and then we have a spark to ignite the gas. And I don't know how much you can see the flame. It looks like you can see it a little bit. It's kind of a bright background there, but you can hear it. Hopefully, you can actually hear that flame. So as we get that going, in order to drive all of that out of there, it's going to take a considerable amount of heat to do that. This will actually start to get red hot in and around the base of this crucible. And crucible is a really good thing to heat things in chemistry to super high temperatures. In AP, we do a little chemical reaction inside of the crucible. But you definitely, you want to hear it, and you can see that's a real nice heat source that we're using right there. Okay, now I'm going to hit the pause because we are going to heat all three of these. The amount of time we're going to heat it on that flame is 10 minutes to drive every last water molecule out of it. Okay, so I'll hit the pause and I'll be right back and show you what our product looks like. And 10 minutes has passed. That's the efficiency of a online lab. We can just have the time go right by. I'm going to kind of bring you guys a little closer to this one. We won't do this for the other ones, but just to kind of see what that product looks like. I don't want to burn my computer here, of course. But you can see is the crystals are kind of white, and you see a little bit of darkness in there. You can't burn them, but you'll also see if you look closely at that flame that it really gets nice and red hot around there. You can just see that we are getting that thing pretty toasty in there. Okay, so we're gonna turn this off right now. And one important thing, if I were to grab that right now, obviously it would result in a pretty bad burn. I did have a student do that once. It was actually one of the most impressive things I've ever seen. He grabbed it and went, and set it gently down instead of like throwing it. He was on the football team at the time when I was coaching, so he got a starting spot out of that because it is one of the most BA things I've ever seen in the lab, I'll tell you. So anyway, we've got this all done heating right now, and I did have the cover on there while I was heating it. But you gotta let this cool. You can't just plop it right onto a cold metal pan. If you do that, it's going to crack. So guess what? 5-minute waiting period, of which will be instantaneous for you. Okay, so I've been letting this sit here for 5 minutes. It's nice and cool right now. Again, way different looking than the beautiful blue crystals that we started with. So I'm going to pop that on there, and you can't forget that we decided, hey, there might be a little bit of product on this. Now notice I'm handling with the crucible tongs. Probably cool enough, at least the top where I could touch it, but you don't ever do that. And you don't ever plop it onto a cold lab table. We use that, that's where that wire gauze comes into play that you did such a beautiful drawing of in the pre-lab. Okay, so we are now ready for the crucible, the cover, and the hydrate. Okay, so no, I'm sorry, the crucible, cover, and the anhydrous salt. Okay, so crucible, cover, and anhydrous salt is what we're going to be weighing right now. So that's what's inside there. Oh, and you can put down, and you don't have to write this every time. We'll always say anhydrate or anhydrous salt. Anhydrate is just put AN in front of the hydrate. If you want to do that in your notes, you can use anhydrate. So the crucible cover and the anhydrate is a mass of 23.49 grams. Okay, that's 23.49 grams. And the other thing is, if I would have plopped that on there when it was hot and it didn't crack, the mass would be going up and down like crazy, because you create these little tiny weather systems, actually, because you got that hot and cold, and so when that little tornado's on there, that causes the scale to kind of go up and down. Sort of a fun little fact there. Okay, so we are now ready to finish our calculation. So this is really important that you understand this and write it down with detail. So we just measured crucible cover and the anhydrate. So now if I subtract our original crucible and cover, I'll get the mass of the anhydrate. Okay, so that was that little picture you did in the pre-lab. The white one was the anhydrous salt, or we'll just call it the anhydrate. So when you subtract that, the 23.49 minus the weight of the crucible and cover, 21.71, you get a mass of 1.78 grams. So 1.78 grams is mass of the anhydrate. Okay? So it went down, was 2.79, now it went down to 1.78, which it should, because water was leaving it. Those little water molecules embedded in the crystal are all gone, and trust me, they did not stand a chance in there at that temperature. You saw how red hot it was. Okay? So that's the mass of the anhydrate. But that doesn't help us with our calculation, because our final calculation we want is mass of water over mass of the hydrate. Well, we've got the mass of the hydrate, so what good does the anhydrate do us for that calculation? So this is where it's a little bit tricky, and you want to be careful with this. Okay? So what you're going to do is you're going to take the hydrate minus the anhydrate, and that will equal the mass of the water. So 2.79, and you should write this down, because like I said, I'm not going to walk you through on the other ones. I'm just going to give you, we'll go up through the mass of the anhydrate and the container, and then I'll say, you guys go ahead and finish the calculations. All right? So now that turns out to be, so when you take the hydrate minus the anhydrate, 2.79 minus 1.78. Like I said, have that written down. And that equals 1.01 grams. That's the mass of the water. Well, mass of water over the mass of the hydrate equals the value of the percent of water in the hydrate, which is the whole purpose of this lab, finding the percent of water in a hydrate. Okay? So, divide those out. 1.01 divided by, which is the mass of the water, divided by 2.79, mass of the hydrate, and then times 100. And crunch those numbers. Hopefully you have your calculators out. What I get when I do that is 36.2%. So I was actually pretty happy about this, because theoretically, what you guys did as homework is 36.1%. So we were very, very accurate. There's the word you're looking for. So we got accurate results using the crucible and the cover. Now in the second video, we're going to do 2 other methods, and it'll be a lot shorter. I'll just give you the data pretty much for that.